we're going to look at this special box over here. It doesn't look like much at the moment, it's just a wooden box. But inside we have something called an Enigma machine. This was used in World War II by Nazi Germany to send secret messages. If we open it up and look inside, this is what we have. If you look at it, it does look like a typewriter, and that's pretty much how it works. But we'll try a message with it. So I'm going to send the message hello. I'm going to type in hello into the Enigma machine. So let's try this out. So H for hello. And if you can see, the letter P lights up. So H becomes P, that's the code. Let's try E. E becomes W. L becomes B. The second L in hello, let's try it, becomes Z this time, and then we finish it off. Let's do O. Oh, and that's B again. That's interesting. So this code was a much more difficult code to break. Old-fashioned codes would have double letters, and they would become double letters. That was a clue. It helped you break the code. This is different. Double letters may not necessarily be double letters. Let me show you how it works inside. So let's take a look inside the machine. We open it up, unscrew the lid, open the lid up, and this is inside the Enigma machine. These three things at the top are called rotors, and inside the rotors, imagine lots of crisscross wires, all mixed up. It's like spaghetti, mixed up wires. So let's have a look what happens. I press a letter, and if you can see that, the rotors move, they turn. Now, inside those rotors, like I said, you have crisscross wires. In this compartment up here at the top, we have a battery. That's actually a modern battery. We've converted this. This is a modern battery. And this is just a simple circuit. This battery is connected to this bulb. So it lights up. It's a simple circuit, that's all. But the wires are inside these rotors, and they move, they turn. So when the wires turn, it will connect the battery to a different bulb. And that's why it will change. So we'll try this out. If I press it again, this will move, and now the battery connects to a different bulb. Do it again, now it's here, now it's here, and it will keep changing. That's why. How do you decode a message? This is useless if we can't decode the message, so let's try and do that. If I put this down, let's try and send a message like hi. I'm going to say hi. So first of all, what do we get? H becomes Z. I becomes L. ZL is the code. We need to reset the machine. We're going to set it back to where it started. I'm going to move this rotor backwards 2 places.
Okay, now hold a second, I will come closer to you. Okay.
Great. So I'm going to move this rotor backwards 2 places. 1, 2. That's reset the machine to where it began. Now we're going to type in the code. The code was ZL. So Z, let's see what happens. Oh, misfire. Let's try that again. We'll cross our fingers. Z. Wiggle. We fix the machine. We hope it works. Let's try this again. We're going to type in the code ZL. Z. Oh, maybe it was different. What was the code? Was it ZL? Mm-hmm. Don't say yes. Okay, we'll have to try that again. It didn't work. It's old. It's 75 years old. We'll have to try that again?
Yep.
So I'm going to have to do hi again, we get a whole different setting.
No.
Try a different setting.
Okay.
So, how do we decode the message? So I'm going to show you how to do this. We're going to type in something easy. I'm going to say hi. Let's type in hi first of all. Let's find the code. H is G. And I is Z. GZ. That's the code. Now, this rotor moved when I typed in hi. I'm just going to move it back to where it started. 2 places, backwards. 1, 2. Now that's reset the machine. We're going to type in the code now, GZ. So, G. Try that again. No luck. That should be no problem. I will literally have to test this now. No, it's fun. Work.
Okay, we can skip that part, and you could you could maybe keep the machine open and go about this how it was used and its meaning in the World War II.
There we go. I can get this to work. Can I try one more time?
Okay.
So, how do we decode the message? So, I'm going to type in a message. I'm going to say hi, because it's nice and short. So, let's do this first of all. We're going to send the message hi. The code is A, D, A-D. Now, this rotor moved when I typed in hi. It moved 2 places. I'm going to move it back to where it was. Backwards, 1, 2 places. That resets the machine. We now type in the code instead. The code is AD. Let's try. We type in A becomes a H. And if we type in D in the code becomes an I. Hi. And you get the message back again. It's a very clever machine. So this was the machine that Nazi Germany were using to send their secret messages, their secret plans. If we can break this code, we will know the secret German plans. And that's what we did. Their idea, their plan, was to cut off our food and supplies. We had ships travelling the Atlantic with food and supplies on them. If they can sink those ships, they block our food and supplies. If we can avoid the German ships, the U-boats, if we can avoid them, then we can get those supplies through. So that's what we did. So we had to break this code. There is a flaw with this machine. The Germans thought it was unbreakable, and it's a very good machine. There is a flaw in the machine. A letter will keep changing. If I press A, it keeps changing. There's no pattern to this. And eventually, all the letters will light up. Except for one letter. And that's the letter itself. If I keep pressing A, it would never light up A itself. And you can use that as a clue. It's a very small clue. It's only a tiny thing. But it's just enough to start breaking the Enigma code.
Could you name 3 of the most important codes that were ever used in the history? Yes.
Yeah. So I'm very interested in the history of codes, and I guess the most important codes in history. No history of code breaking is complete without mentioning the Caesar shift. It was used by Julius Caesar in the Gallic Wars. We're talking 2,000 years ago. It substituted one letter for another in a very simple way. But that was one of the most important. Simple today. After that, the Vigenère cipher. It was invented by a French diplomat, Blaise de Vigenère, and this was different. It kept changing which code you used. Old-fashioned codes would use the same code for the whole message, whereas Vigenère kept changing. And, well, I think the third most important would have to be the Enigma machine itself. In the 20th century, it had become necessary and possible to mechanize code making. And machines like the Enigma machine were in fashion at the time. But Enigma was special. It was one of the best machines of its type around.
And your message to people who are interested in mathematics or who would be interested in mathematics?
Yeah. Well, people have this idea that mathematics is a very dry, dull subject, that you have a formula at the top of the page and you do your work and you get x equals 6 at the end, and that's not true. If mathematics was like that, I wouldn't do it. The mathematics, if you talk to mathematicians, we talk about beauty, we talk about elegance, we talk about it like it's music, like it's art. It involves creative thought, intuition, guesswork even, and it is a creative subject. I create something that has never been done before.
Okay, I will just take a few close-ups here, and then the next group is ready. The next group is waiting. But yeah, it's the code breaking from the military point of view. It's one of the reasons you are not in the, one of the reasons that you are not in communist Finland this day. It's we had one really genius guy who started building up radio intelligence networks in early 30s already, and he also found some excellent Finnish mathematics guys who were recruited to work for him during the war, and they were already in the Winter War they were already reading Russian codes very well, and later almost in real